Hey, this is Mr. Gold, and I'm going to be helping you review right triangle trigonometry. So if we have ourselves a right triangle, remember that's a triangle with a right angle, we of course have our two legs of the right triangle, side A and side B, and we have our hypotenuse, side C. Now, if we label one of the angles of the right triangle as theta, and we say that theta is an acute angle, okay, remember acute angle means between 0 and 90 degrees, or between 0 and half pi radians, then we can label all the sides A, B, and C of the triangle with respect to this angle theta. For example, side A would be the side that's adjacent to theta. Side B would be the side opposite theta, and side C would be the hypotenuse. Okay, now using these labels of these sides, we can come up with 6 different functions, or relationships, or ratios, even better, of the sides of the right triangle, which we call trigonometric functions of the acute angle. So the sine of theta, for example, would be the ratio of this side B over side C. Sorry, I almost told you the wrong thing. Side B over side C. Now, what I'm going to do is I'm going to abbreviate adjacent with capital A, opposite with the capital O, and hypotenuse with capital H. Now, so the sine of theta could be side B over C, or we could also say it's the opposite over the hypotenuse. The cosine of theta would be the side A over C, which would also be the adjacent side over the hypotenuse. Tangent of theta would be the opposite side over the adjacent side, or B over A, or opposite over adjacent. The cosecant of theta would be C over B, or the hypotenuse over the opposite. The secant of theta would be C over A, or hypotenuse over adjacent. And finally, the cotangent of theta would be A over B, or adjacent over opposite. Okay, now, knowing these 6 ratios, we can come up with several relationships that we call identities, or the fundamental identities of trigonometry. The tangent of theta is equal to the sine of theta over the cosine of theta. Okay, so there's one. And another is the cotangent of theta is equal to the cosine of theta over the sine of theta. Now, we call these two the quotient identities. Next, we have what we call reciprocal identities. The cosecant of theta is equal to 1 over sine of theta. The secant of theta is equal to 1 over cosine of theta. And the cotangent of theta is equal to 1 over tangent of theta. And lastly, we have 3 Pythagorean identities, such as sine squared of theta plus cosine squared of theta equals 1, tangent squared of theta plus 1 equals secant squared of theta, and cotangent squared of theta plus 1 is equal to cosecant squared of theta. Now, we can use either our fundamental identities or the definitions that we learned in the previous up there before we scroll down to help us find the values of the different trig functions if we only know one of them. So here we're going to go over how to find the values of all trig functions if only one function is known. So an example would be, given that the sine of theta is equal to 4 over 5 and theta is an acute angle, find the value of the other functions. Now there's two ways that we can solve this. The first way to solve is by using the definition. So we want to start by drawing a right triangle. So we do that. We draw a right triangle, and we go ahead and label one of the acute angles as theta. Now, using the given trig function, we're going to assign values to two sides of the triangle. So we were given that the sine of theta equals 4 over 5. Now remember that the sine of theta is the same as the opposite over the hypotenuse. So that means that the side opposite of theta over the hypotenuse will give us a ratio of 4 over 5. So we could simply say that this side is 4 and the hypotenuse is 5. Okay, so we've gotten two sides of our triangle. Now third, we want to use the Pythagorean theorem to find the value of the third side. So I'm going to give you a second to go ahead and determine that. You may know right off the top of your head what the third side has to be. If you don't, you can easily use Pythagorean theorem to find that third side. So let me give you a moment to do that, and when you figure it out, just hit continue at the bottom of the screen. Welcome back. So you probably figured out this third side has to be 3 because 5 squared is equal to 4 squared plus, if we call it a, because it's the adjacent side, a squared. Solve that for a and you'll get 3. You may recognize this as a Pythagorean triple too, the 3, 4, 5 triangle. So now we have our three sides of the triangle, so we can make our ratios by using the definitions. So remember, we have sine already. Remember, cosine of theta is equal to the adjacent side over the hypotenuse. So that would mean it's equal to 3 over 5. Okay, and then we can continue on with all the definitions of our functions. So tangent of theta equals opposite over adjacent, and so on. And I'll let you do that on your own time. The second way that we could solve this is to use identities. And here a hint is to find sine and cosine first, and then that really helps you. Once you have sine and cosine, we can pretty easily determine all the other functions. So if we use the Pythagorean identity, sine squared of theta plus cosine squared of theta is equal to 1. Now we were given in our original problem, we're still using the same example as above. And remember that the sine squared was 4, or sine of theta was 4 over 5. So sine squared will be 4 over 5 squared. Plus cosine squared of theta is equal to 1. And then we're going to solve this for cosine. So 4 over 5 squared gives us 16 over 25. Plus cosine squared of theta equals 1. If we subtract 16 over 25 from both sides, cosine squared of theta equals 9 over 25. So the cosine of theta will be equal to 3 over 5. Okay, which is the same thing that we determined up here, so we're pretty sure that we're right on that. Now, what we can do is use the cosine, and we also know the sine is 4 over 5, to go ahead and determine the others using identities. So remember the identity that said tangent is equal to sine over cosine. Well, now we can plug in our sine, our value for sine, our value for cosine to determine tangent is 4 over 3. And we can do that with cotangent, 1 over tangent, secant, 1 over cosine, cosecant, 1 over sine. And we can get all of our other functions using identities. Okay, so let's move ahead to the idea of complementary angles. Well, remember from geometry, complementary angles, of course, have a sum of 90 degrees. They add up to 90 degrees. Now, in relation to right triangles, the acute angles of any right triangle are complementary. Because remember, if we look at our diagram, we know that the sum of the interior angles of a triangle are 180 degrees. Well, a triangle has a right angle, so that's 90 degrees. So that means that the other two angles, alpha and beta, have to add up to 90 degrees. Okay, so they are complementary because they add up to 90 degrees. Now, if we label this diagram, first, if we label the sides with respect to beta, we see that this side, side A, is adjacent to beta, and side B is opposite beta. Now, if we label the sides with respect to alpha, we have side B is adjacent to alpha, and side A is opposite alpha. So look what happens when we, if we look at the sine of beta, Okay, the sine of beta, remember opposite over hypotenuse, will get side B over C. Now, what if we look at the cosine of alpha? Cosine of alpha gives us adjacent over hypotenuse, or B over C. They're the same values. The sine of beta and the cosine of alpha are both B over C. They're the same thing. Because of this, we call sine and cosine cofunctions. Okay, sine and cosine are cofunctions. Tangent and cotangent are cofunctions. And secant and cosecant are cofunctions. So if we took the tangent of beta and the cotangent of alpha, they would give us the same thing. And the same with secant and cosecant. Now, so the complementary angle theorem tells us that cofunctions of complementary angles are always equal to each other. Okay, so what this means is that the sine of theta will be equal to the cosine of 90 minus theta. The cosine of theta would be equal to the sine of 90 minus theta. Tangent of theta equals cotangent of 90 minus theta. Cotangent of theta equals tangent of 90 minus theta. Secant of theta equals cosecant 90 minus theta. And cosecant equals secant of 90 minus theta. Now, of course, we can also substitute half pi radians for 90 degrees, and that would hold for all of these as well, because remember, 90 degrees and half pi radians is the same thing. So, we can use this now to look at an example. Which value is equal to secant of pi over 6? Is it A, the cosecant pi over 6, the cosecant pi over 3, or the cosine of pi over 3? Go ahead and work this out on your own and select the correct answer choice A, B, or C at the bottom of the screen. Very good, the correct answer choice is B. If we take a look at the solution, the secant of pi over 6 is going to be equal to the cosecant of pi over 2 minus pi over 6. Okay, so we want to find the complement of pi over 6. So when we subtract pi over 2 minus pi over 6, we get pi over 3. So the cosecant of pi over 3 is equal to the secant of pi over 6. Okay, well, I hope this helps you understand right triangle trigonometry. Good luck.